Well, children, today we'll redo chapter 2, which is motion in one dimension. Now, you know that everything around you is moving, and this movement we can study under two things. One is kinematics, which means that is describes motion, and other is dynamics, which deals with the causes of motion. So we'll be confining our studies to kinematics. Now, what does one dimensional motion actually mean? It means motion along a straight line. Now, all the physical quantities that are known to us, can be categorized under two categories. One is scalars and other is vectors. Now, vectors are those quantities, those physical quantities which need both magnitude and direction for their expression. That means they need a value also, and the direction is also to be specified. For example, displacement, velocity, acceleration, momentum, force, etc. And second is scalars, which do not require any direction. Rather, they can be expressed only in magnitude. For example, you have distance, speed, time, mass, energy. Now, when you talk about motion, then any motion involves three concepts, which are displacement, velocity, acceleration. These concepts can be used to study objects in motion. So now we'll start talking about these concepts individually. Let's start with what is distance. Now, distance means how far you have traveled, regardless of direction. That means I can say distance is length of the path traveled, whereas displacement is with direction. It is the path or the length covered with direction. So where you are in relation to where you started includes direction. That means length and direction both are displacement. Now, can you see, let's see how can you compare to. Can you see this curve? This is indicating one position where you start and it leads to the another position where you end in a zigzag manner. So this is the path covered by you. So when you drive in such kind of a path, then your odometer, let's say, will give you your distance, but your displacement is the shortest directed distance from start to stop. So just see, this arrow indicates the displacement, whereas that zigzag path was the actual path traversed by you. So the arrow is displacement, that means the shortest distance along with the direction, whereas the zigzag path is the path covered, the distance, no direction involved in it. Now, when we talk about different terms in physics, we many times come across the word rate. A rate measures how fast something changes. So in physics, remember, a rate is always calculated as a quantity divided by time. So rate is equivalent to rate with respect to any physical quantity means change in that quantity. Q stands for that quantity and time for that quantity to change. Now here we'll compare distance and displacement. So if you ask what is the difference between distance and displacement, then remember, distance is the length of the path actually traveled by a body in any direction, whereas displacement is the shortest distance between the initial and the final positions of a body in the direction of the point of the final position. Now, distance between two given points depends upon the path chosen. Whatever you travel, that is your total distance. Whereas, displacement between two points is measured by the straight path between the points. Now, distance is always positive. That means if you move, then some distance is covered. Whereas, displacement may be positive or negative or even zero. So I can say that distance is a scalar quantity and displacement is a vector quantity. Remember, distance will never decrease, but displacement may decrease and become zero.